Hello, welcome to our presentation on video streaming with RTSP and RTP protocols. Real-time streaming protocol is used to establish and control media sessions between client and server. The transmission of streaming data itself is not a task of the RTSP protocol. It rather acts as a network remote control for multimedia servers. RTSP uses TCP to maintain an end-to-end connection, and messages are sent by the client to the server, some from the server to the client. RTSP facilitates real-time control of playback of media files from the server.
Having discussed the theory for the protocol, let's go to the client-side socket-based programming. Here, as we write this command into the command prompt, the local host is given as the server address, 5540 is given as the server port, 5541 is given as the RTP port, and this movie dot is given as the file name. As we write all these constants into the client function, we go to the client.py file. Here we have all these constants that are initialized, and this init function also has all the variables that are initialized. This function is used to create the GUI window that is displayed as the output. The setup button is required, the start button is required, pause and the tear down button is required. Here we have a setup function which says that if the state is equal to the initial state, then we can set up the the button. The exit client function which says that if the tear down button is as the setup button, then we can call this destroy function that will terminate the whole process. The pause movie which states that if the state is equal to the playing state, then we can pause, and play movie which states that if the state is equal to ready, then we can play the video. Listen RTP function which states this function RTP packet. The RTP packet.py is a separate file which states that here we have header as an array of size header size which is equal to 12. So we have index from 0 to 11. This is the function which we need to complete. Here the header is divided into four parts, namely 2 bits, 1 bit and 4 bit, which is equal to 8 bits and 1 byte. Here 4 bytes is equal to 32 bit, which is equal to the header size. So the header is first divided into 4, then the header is divided into 2, the sequence number is divided into 2, the timestamp is divided into 4, similarly the SSRC code. We also have the header as well as the payload. The payload is the actual information that we need to get get to the server, and the header is the header which addresses the server as well as the client. Here, this is the decode function which takes the argument as the array and returns the string as this header. Similarly, the payload. The version function gives us the version. The sequence number gives us the sequence number. Similarly, the timestamp. Payload type. Get payload will return the string which is the payload, which is the actual information, and get packet will return us the packet which contains the header as well as the payload. Now, as we return from this function, the data which we have derived should be decoded, and then this function gets over, and we need to complete here set RTP request. When the request code is equal to the setup and the state is equal to the initial state, then we increment this sequence number, and then we try to print these things which states their setup plus file name, version, and sequence number. Similarly, the transport protocol and the RTP port. Similarly here the play button, if the request code is equal to play and the state is ready for playing, then we increment the sequence number and then we print these lines, which has the only difference of here play button, rest everything is same. The sequence code is if the sequence code is equal to pause and if the state is equal to playing, that means that initial state is equal to playing and now we want to pause and the request code is equal to post, then we increment this sequence number and then we print pause. Similarly, if we want to tear down, if the request code is equal to tear down and the state is not equal to the initial state, then we try to tear it down and then we increment the sequence number by 1 or else we return because we don't have any other button in the GUI base. So this was the function and this was the 3 file from the client side. Now we will go to the server side.
First of all, in this function, this condition will execute, and after that, if condition is satisfied, then this main function will execute. In this function, first of all, we are uh, assigning the server port with the parameter, which is first parameter. Otherwise, this line will print, and we are making socket out of it, and we are binding this socket with port number, and we are limiting the request by 5. After that, this the server will go in waiting mode until any client request is come. After the client request will come, the server worker file will execute. In this server worker file, first of all we are initializing all the variables. After that, this init function will run. This init function, we are initializing this client info variable with this parameters client info variable. After that, in this receive request function, we are making connection socket, and while connection socket is receiving, we are taking it and we are decoding it. In this process RTA request function, we are splitting our request line like a file name and sequence number. If the request is setup type and our state is init, then we are printing this message, and we are opening this file into client info, and we are initializing this state as a ready mode. Otherwise, we are giving error, and if we are success, then we are uh, giving response message as a OK. If the request type is play and our state is in ready mode, then we are uh, uh, we are setting our state as a playing mode, and we are uh, making a socket in a client, and we are replying sending response message as a OK. If the request is coming as a pause, then and request is a pause and our state in playing mode, then we are initializing our state as a ready, and we are sending response as a OK. And if we want to terminate the process, then we print this message and we send this response, and we are closing our setup over here.
Now we will see the live video streaming. First, we will open the command prompt for the client. Then we will open the command prompt for the server. Now we have to switch the path of the command prompt where our file is located. This is for the server and this is for the client. Now the client the server file is called by this represents that the server is going to listen from now, and here is the client file, which is client launcher.py. From this file the client will set up the connection over here, and we will get this type of window, which is the GUI base. Now we will try to set up. When we try to set up, the state is changed from initial mode to the setup mode, and here we can see that the things which we will printing from the client side is printed over here, as well as here the transport protocol is also displayed with the sequence number. Now as we have set up, let us play the video. During the playing of this video, the video is seen over here, and we can see that the sequence number going to increase here, and the process is equal to the play process. We can see that initially the process was setup process. Now if we pause this video, the sequence number at 284 is paused. Here the status is equal to processing paused, and the sequence number is equal to 3. When we play, the sequence number gradually increases and the status is equal to play. Now the thing is tear down, and so the video is terminated. Also, if we run the video once again, set up and play, if we do not tear down until the last time, at last the video pauses, and then we need to close the window. Now that's done. Thank you for your attention.